In 1650, a massive earthquake tore through the city of Cusco. The tremors reduced the Spanish colonial church of Santo Domingo to a pile of rubble, leveling the heavy European-style walls that had stood for less than a century. Yet, once the dust settled, the foundation beneath the wreckage was still intact. This curved stone wall, built by the Incas 5 centuries earlier, survived the shock completely unscathed. The same pattern repeated in 1950. A second earthquake leveled the rebuilt church, while the Inca stonework beneath it held firm once again. The Spanish had viewed the Incas as primitive for their lack of iron tools, the wheel, or mortar. But European building techniques failed where indigenous engineering thrived, leading the Spanish to eventually graft their modern church directly onto the dark gray Inca foundation. To see how these walls survived, we must examine the specific ways the Incas synchronized their architecture with 2 forces, the heavens above and the tectonic plates below. At the high-altitude peaks of Machu Picchu, the stone ruins served as a massive precision astronomical instrument. This is the Intihuatana, the hitching post of the sun. Carved from solid granite to function as a solar computer, it is shaped so the sun sits directly above the pillar at noon on the winter solstice, casting 0 shadow to predict the changing seasons. The Temple of the Sun used a curved wall and specific windows to track these movements, perfectly framing the sunrise on the days of the solstices. This data allowed the Incas to synchronize their agricultural cycles and empire management with the mechanics of the solar year. While roofs faced the sky, the foundations of these buildings were designed for a volatile ground. The Andes sit atop a landscape defined by extreme tectonic activity. The Incas used dry stone masonry, where individual blocks were polished to fit together seamlessly. Without mortar to create a rigid, brittle bond, the walls remained flexible. During an earthquake, these stones dance. The rounded edges and inward-leaning walls allow the heavy blocks to shift and grind against each other, dissipating the energy of the seismic wave through friction before they lock back into their original positions. This mastery of the environment traces back 5,000 years to the Norte Chico civilization, who developed an early form of what engineers now call base isolation. They used shikra backs, mesh nets filled with river rocks, to create foundations for their temples. This layer decoupled the temple from the ground, absorbing the shaking. A modern structural base isolator performs this exact same function today. Modern skyscrapers rely on high-tech dampeners to stay upright, but the ancient Andeans arrived at these same principles using plant fibers, woven mesh nets, and river cobbles. This engineering trajectory was interrupted in the 16th century when Francisco Pizarro and Spanish forces arrived in the Andes. The Inca political state collapsed with incredible speed, under the pressure of European diseases, civil war, and superior weaponry. The execution of Emperor Atahualpa effectively decapitated the central authority of the empire, handing control of the territory to the Spanish. But while the Spanish could replace the governance and religion of the region, they were physically unable to tear down the walls. The Inca political state was dismantled, yet its physical foundation remains. 5 centuries later, the stones at Cusco and Machu Picchu continue to absorb seismic shocks and track the solar year, a record of environmental mastery that